You know, it's kind of wild when you stop and think about it, that there's this entire hidden world that exists all around us, in everything we touch, in every single object. There's this universe of intricate structures, a secret architecture that's completely invisible to the naked eye. So today, we're going to pull back that curtain.
Okay, so what are we looking at here? At first glance, it's just a speck of dust, right? A tiny metal nanoparticle. But what if I told you it holds a secret? A hidden order that could totally change how we build things in the future. Today, we're going on a nanoscale detective story to figure out what it's hiding.
Right, so this little particle has a pretty cool origin story. It was actually found inside a polymer, which is basically a material they're designing for making the money of the future. How cool is that? But when scientists zoomed way, way in with a powerful microscope, well, what they saw was just baffling.
I mean, even with one of the most powerful imaging tools on the planet, the arrangement of atoms just looks messy. It's not a neat, tidy crystal pattern like you might expect. It's just a jumble, a real puzzle that left scientists completely scratching their heads. So how in the world do you make sense of that?
Well, to solve a nanoscale mystery, you need a nanoscale detective. And in our story, that detective isn't a person. It's a powerful analysis technique, a totally new way of seeing that can cut right through the noise and find the patterns hidden inside. It's called Digital Darkfield, or DDF for short. And honestly, the best way to get your head around it is to think of it like a digital tuning fork. Imagine you're listening to a massive orchestra, 100 instruments all playing at once. It's just a wall of sound. DDF is like this amazing tool that can tune into the exact frequency of just one of those violins and then show you exactly where that sound is coming from. It isolates one specific pattern from all the chaos.
Okay, so let's break down how that works. First, you start with that super complex, jumbled image. That's our whole orchestra. Then you use the software to lock onto one specific repeating pattern you're looking for. That's our violin's note. The program then scans the entire image and highlights every single place that specific pattern appears. And when it does that, a hidden structure just emerges from the noise.
So, are you ready for the big reveal? It's time to take our digital tuning fork and apply it to our mysterious particle from the money of the future. Let's finally solve this thing.
Okay, here it is again, our clue, the confusing mess of atoms we started with. Take a good look, because what you're about to see is the exact same particle, just viewed through a completely new lens.
And there it is! Wow, all that chaos is just gone. And in its place is this absolutely stunning, highly ordered pattern of shapes. This beautiful, intricate structure was hiding in plain sight the entire time. I mean, this just brilliantly shows you the power of this technique.
You know, the scientists who discovered this were so struck by its beauty that they described the particle as being, and I love this quote, replete with hidden butterflies and bow ties. And you can absolutely see why. It's not just data, it's like a tiny work of art hidden at the atomic level.
So what are we actually looking at here? Well, before DDF, we had a confusing pattern of atoms. But after DDF, a clear structure is revealed. It's a very specific, five-fold symmetric arrangement known as an icosahedral twin. A complex, beautiful, and highly ordered structure that was completely invisible just moments before.
But look, this isn't just about finding pretty patterns in one little particle. This technique is a total game changer across so many different fields of science, from understanding the cosmos to building the technology of tomorrow.
Get this, scientists are using it to analyze actual stardust. We're talking pre-solar dust grains that were forged inside dying red giant stars billions of years ago. By looking at the structure of these tiny graphite onions, they can understand how the very carbon atoms that make up our bodies actually traveled between the stars to get here. It connects the unimaginably small to the truly cosmic. And then, right back here on Earth, DDF is absolutely essential for building our future. Engineers use it to map tiny strains and defects in silicon, which is crucial for making the next generation of computer chips faster and more powerful. It helps them locate quantum dots in new devices and find tiny flaws that could cause a whole material to fail. And just to give you a sense of the insane power we're talking about, DDF can map shifts and strains in a material down to the picometer scale. That is a trillionth of a meter. It's a scale that is almost impossible to wrap your head around, and yet we now have the tools to see it and measure it with precision. You know, this brings us to a fascinating thought. For basically all of human history, we've been limited by what our own eyes can see. But now, with tools like Digital Darkfield, we are systematically shattering that barrier,
gaining the ability to see the fundamental structures that build our entire world.
So the big question this leaves us with is this. We can now see the invisible. We can find hidden butterflies in a speck of dust. So what else is out there, hiding in plain sight, just waiting for us to tune our instruments to the right frequency? What will we choose to look for next?